Okay, it is time for us to move away from the whiteboard for a little while and begin some coding. That's right, we are going to begin coding our DAG example application right now. So if you are trying to solve knowledge review number 7 on your own, you may want to avoid watching this video until you run into a situation where you need to compare your results to ours, or you have simply run into a brick wall and you have exhausted all of your different avenues of trying to solve the problem at hand. So once again, we are about to begin coding. So in this video, what we're going to do is create the skeleton for the transform node class and get it up and running. But in creating the skeleton for the transform node class, let's think all the way back a few videos where we said that transform node is going to be derived from the node class. So in order to get the transform node skeleton in, we are going to need to create the node class first. So with that, Logan, let's go ahead and create a console application.
All right. Let's begin a new project. That project will be a console application. And I want to address the name, since this is, as we've been discussing, a somewhat larger project. Let's start from the beginning and give it a name.
Okay.
The name I want to give it is Knowledge Review 7 DAG. So I'll abbreviate that to knr7.dag.
Okay.
And that will be our project name. We'll hit OK to that to have the project created. And we now have our project, our base main program, and our namespace set up for us.
Okay, fantastic. So now let's go ahead and get a little bit of our organization in place. Let's go and create our classes folder.
All right. Going up to the project, I'll add a new folder. We'll call it Classes.
Now, let us begin with our first class, the node class.
All right. So into Classes, I will add a new item. This item will be a class, and it will be called Node.
Now, as everybody may remember, what is the node class's primary functionality? Well, to hold the name of the node.
And before I begin, let me also strip off the classes part of the namespace. We'll keep this all under the project namespace. All right, beginning with node, we need to have a name. I'm going to make a protected string field in order to hold the actual name. So I've got protected string name.
So this gives everybody who extends node access to a name, but externally they don't have access, so it'd be a good idea for us to turn right around and create a public property giving access to name.
So let's make our public property a string property called name. And inside of this property, let's give both get and set accessors. So the get accessor will be simply returning the current name. So return this dot name. And the set accessor will set the name, so this dot name, to the given value. And that should be all we need for the name property.
All right, now we've got one more thing that's really cool that we're going to add in as some special functionality to the node class. And that is going to be an override of the toString method. Now remember, all classes derive from object. Okay, so we always start out with object as the very first class, and that is provided to us in system. And object has a few things that come along with it, and one of the things is toString. And we've used toString several times in the past, haven't we?
Right, and dealing with numbers and structs, it was also very convenient that we could call upon toString in order to give a textual name instead of the held value for any given thing that we were trying to show.
But in this particular case, we are creating a console application, so there's going to be a bunch of write lines taking place, right?
Right, a bunch of write lines where we're going to use string values of things to be outputted to the console.
And to keep us from having to constantly say, you know, this particular node dot name, wouldn't it be nice just to say this node?
Right, to be able to put a node directly into a console write line and have a name written out instead of the class. So instead of seeing transform node or node written to the console, you would see a relevant name like, oh, this was shape 5 or transform 2.
Exactly. So through polymorphism, we can actually change the toString behavior that comes from the object class, can't we?
Right, we can simply override it.
Actually, let's go ahead and show them the toString method that's in the object class real quick.
Right. What I want to do is load up the object, or excuse me, let's go to other windows, bring up our object browser. So inside of the object browser, I can look into System, open up the system namespace, and inside of here, let me do...
Just do a quick search for it at the top.
Yeah, do a search for...
Object. Da-da-da. Here it comes.
And inside of object, we have system.object. So this is our base for all classes and supports all classes in the .NET framework, yada yada. The cool thing is, if we look at the members of the base object, we have several things, including toString. So there we go. That's where toString comes from. If we look at it, it is defined as virtual. So
Sweet.
We're free to override it.
That's right. So we can give it our own implementation, which is exactly what Logan is about to do right now.
So we're done with the object browser now. Let's go into back to our node class. Let us put in a public override for the toString method. Now toString returns a string, so this is going to have to be of type, or a return type string, and the method is toString. It recognizes that there is a toString method we can override, so if I select that, we get the body thrown in place for us, where it is trying to return base.toString, so it'll have the current behavior. We can replace this return with a return this.name, and now toString will give the name of the node instead of whatever the base object was going to give it.
Exactly. Okay, beautiful. So that gets node set up and ready to roll. So let's go ahead and move on to the transform node. So let's create that.
All right. Back to the classes folder, we'll add a new item, and this will be the transform node class. So we've got transform node. We'll add that in. We'll strip classes off of the namespace. And there we go. Now the very first thing we need to address is the fact that transform node, as a node, needs to extend the node class.
That's right.
All right. Once we're extending, we can address our fields for transform node. The first thing we want to address is the parent of this current node. We want to hold a reference to a transform node parent. So this will be a private transform node field called parent. Next, we had talked about holding a reference to a shape node.
Now let's go ahead and put in 2 comment slashes here, because we don't have a shape node class yet. So since the type doesn't exist, if we were to try to do a quick build to make sure that we haven't introduced any errors in our simple application so far, it would be very unhappy.
And how about we just loosely write a note to this, since we don't have shape nodes haven't been defined yet. Let's just say. Well,
I was gonna go ahead and say code it out, only because in the last video we actually wrote it out in the requirements, so it'll follow our requirements.
We've seen shape node written out.
It's just commented out because the type doesn't exist yet.
Okay.
So we can just do a private shape node called shape.
So talked about the existence of shape nodes. We know that we're going to call them shape. So we'll leave that alone, and we'll put it in place when we actually need them, when we actually have shape nodes defined.
That's right.
All right. Next, we've got a static list in order to hold root nodes.
That's right.
So this will be a private, since we're only going to use it from inside of transform node. It'll be static, so we have it stored in the class, and we'll call it, or excuse me, it will be a list of transform nodes, and it's going to be called root nodes. So we'll have all of the nodes that reside at the root level. Okay,
and of course each transform node, each instance of the transform node is going to contain a list of children, so let's go ahead and create that next.
Okay. Let's have every transform node instance have a private list of transform nodes, and we'll call this list children.
All right, so that's going to take care of all of our fields. Now let's go ahead and move our attention over to the constructors. So time to move on to methods. Let's start with our static constructor. And even though this is a skeleton that we're creating, let's go ahead and throw some code into the static constructor, because its only purpose is to create the new list of root nodes.
Okay, so this is going to be our static constructor. So we'll have static transform node, and inside we simply initialize our root nodes list. So root nodes equals new list of transform node.
Okay, very nice. So now let's turn our attention over to our public constructors. Okay. Our first one just being a simple default transform node constructor.
Okay, so we'll have public transform node.
And we'll revisit the initializer in just a second. So now let's go ahead and do the transform node that will basically take in a string parameter.
Okay, so again we'll have a public transform node, this time taking in a string called name.
Excellent. Now let's go ahead and revisit the default constructor and call upon the initializer this and send it the string transform.
So this way we'll have a default name set up for the default constructor.
Okay, and go ahead and clean up those 2 curly braces for me just to make it look a little more compact. Oh yeah, that looks nice. Okay, so now from there let's go ahead and move on to the functionality, if you will, that needs to exist inside a transform node, starting out with set parent. So let's do a public void set parent.
All right. Here we have our set parent. Parent's going to need to take in a parameter. It's going to need a transform node for the parent. All
okay.
right.
Now let's go ahead and set up our find stuff.
Okay. So the first part of find will be static.
The static, that's right. So we're going to have a public static find that returns a node.
So public static
node
called find.
And it's going to take in a string, and that string is simply going to be the name of the node we're looking for.
Simple enough.
All right, so that right there is the transform node, or the transform nodes type objects find. Now let's go ahead and set up the instance find node method. So let's go ahead and create a public find node that returns a node.
So we'll have public node find node, and this again needs to take in a string name to look for the name of the node.
Excellent. Okay, let's go ahead and move over to an ability to show all transform nodes. Let's go ahead and create a public static void show all.
Just in case you want to say, give us all transform nodes.
Exactly. All right, so with that, now let's go ahead and create a show tree that is going to be an instance method that's capable of showing from where we are and all of our descendants.
Right, showing the tree from the current node.
Exactly.
So this will be a
private void. Yep.
Void show tree, which takes in a depth as an integer. So we'll have int depth.
As discussed in the last video. All right, very good. So just a couple more things, really. I think we got about 2 more main topics to hit, and that is the ability to remove the node. So we need to be able to remove ourselves, and then the grouping stuff. So let's go ahead and set up a public void remove node.
Public void remove node. It doesn't need to take anything in because it's called for an instance.
Yep. And then let's go ahead and set up our 2 different grouping behaviors, one that takes in 2 transform nodes and the other that takes in 1 transform node.
Okay. So the first will be a public static void group, which takes in 2 transform nodes. Transform node node 1 and transform node node 2. Now that takes care of our first group. We have another overload for group that will allow us to group using only a single node. So we'll make an overload called public static void group, this time taking in a transform node, node 1 only.
Okay.
And there we go.
Fantastic. Well, is there anything else that we need? As far as I'm concerned, that's the skeleton for the transform node in place. Let's go ahead and build and make sure it builds fine. And a couple errors we can go ahead and knock out real quick. We've got a few of these methods that return a node. So let's start out by just returning null.
Right, just so we can build the skeleton. So we'll return null from the static find method and return null from the instance find node method.
Right. So let's go ahead and build. Beautiful. So right now it's just giving us some warning about things that have never been used. And outside of that, no errors whatsoever. And that really wraps up everything we wanted to get in place for the start of the application. Basically, we've got our node class, and then extending from the node class, we've got our transform node class that meets all of the requirements that we spec'd out on the whiteboard in the last video. So now that we've got the skeleton in place, it's time for us to start actually focusing on functionality. So that is going to wrap up this video. Thanks a lot.